Hello everyone. Today we're looking at Unit 1, Lesson 4, Substitution and Elimination Continued. So we've spent the past few lessons discussing different algebraic methods to solve linear systems. Today we're really going to take a look at how do we know which method we should use depending on the linear system that's presented to us. So before we get into how do you know which method to use, let's go ahead and try to solve this linear system we have here using elimination. Okay, so we're going to use elimination. And this will kind of lead us into what we're doing today. But notice that the reason I would choose to use elimination for this one is because we have our x term, and it's right above the x term in the other equation. We have our y term over our y term, and we have our constant over our constant. Okay, so when we have them all lined up with that, we should be thinking in our head right away, elimination. I'm going to erase the highlighter for now. But the first step in elimination is that we're going to label our equations 1 and 2. All right, now before we worry about whether or not we need to multiply to get the same magnitude, we looked at this in our review. We need to clear the fraction. So we have these fractions happening here. We need to clear the fraction so that we're working with whole numbers, and it just makes life a whole lot easier. Let's actually, I'm going to move our number of equations over here. So if I think about equation 1, in order to clear the fraction, I need to multiply by the lowest common denominator. So in this case, we're going to multiply by 6 to clear the fraction. And on equation 2, I have a denominator of 6 and 5. So my lowest common denominator, or multiple, is going to be 30 here. So let's multiply everything through by 6 and see where that gets us. So I'm going to do x over 3, and I'm going to multiply this by 6. I'm going to do y over 2 and multiply that by 6. And then finally I'm going to do a negative 3 times 6. All right, and from there, we should do some simplifying. We should see that the 6 and the 3 will just reduce to a 2, so we'll have 2x. The 6 and the 2 on our y is going to reduce to a 3, so we're going to have 3y, and that's going to equal a negative 18. And we're just going to write equation 1 next to that again, so we remember that's our newly transformed equation 1. Okay, for equation 2, I'm going to take x over 6, and again I'm going to multiply by 30, and do my y over 5 and multiply by 30, and then finally we'll do 3 times 30. Okay, so when we multiply 30 times x over 6, that 30 and the 6 is going to reduce to 5. So we'll have 5x plus the 30 and the 5 on our y is going to reduce to 6. So we'll have 6y, and then 3 times 30 is 90. So that is equation 2. Now we haven't even gotten to actually, can we eliminate anything now? Have to figure out, do I need to multiply either of these equations by something to be able to eliminate? So if we look at our x's, we see that we have a 2 and a 5. So I would have to multiply both equations by something to get those magnitudes the same. But if I look at my y values, I have a negative 3 on this y, and I have a positive 6 on this y. So could I multiply an equation by something to get that same number? And the answer is yes. I could multiply equation 1 by 2, and that's going to change my negative 3 to a negative 6, so then I'll have the same magnitude. So we're just going to kind of move down here because we've run out of room. So we'll multiply everything in equation 1 by 2. So we're going to get 4x minus 6y equals a negative 36. Okay, we're not going to do anything to equation 2. We're just going to bring it down to the next line. So we'll have 5x plus 6y equals 90. Okay, and now since they have the same magnitude, but they have the opposite sign, we are going to add equation 1 and 2, And it's always good to, again, communicate that. So we're going to do 1 plus equation 2 in order to eliminate our y's. So we have 4x plus 5x. That's going to get us 9x. My y's are going to drop away because I have a negative 6y plus positive 6y. And then a negative 36. Oh, this should be a 36, not a 30. Sorry about that. Negative 18 times 2 is a negative 36. So I have a negative 36 plus 90 is going to be 54. And then we'll just work to isolate x. So we're going to divide by 9, and we're going to get that x is equal to 6. And now we're going to take 6 and we're going to substitute it into one of our equations. I'm going to substitute it into equation 1 just because the numbers are a bit smaller. So I'm going to sub x equals 6 into equation 1. And I'm going to substitute it into equation 1 where we had gotten rid of the fractions, because again, that'll be easier to work with. So let's just write equation 1 in blue. So my equation 1 is 2, and then I'm going to put brackets where I'm going to fill in what I'm substituting in. Minus 3y equals a negative 18. And then we'll just work to simplify. So we'll have 12 minus 3y equals negative 18. I'm going to bring that 12 over by subtracting. So we're going to end up with a negative 30. And then finally, we'll divide both sides by negative 3. So y will equal 10. Okay? And then the last step, okay, we substituted into equation 1. So we're going to need to check it now in equation 2. So check in 2. So we will do a left side, right side check using my simplified equation 2 as well. So after we cleared the fraction, the left side of equation 2 was 5x plus 6y, and the right side was just 90. So we'll substitute in our values. For x, we'll sub in a 6, and for y, we'll substitute in 10. Now 5 times 6 is 30, 6 times 10 is 60. So you get 90, which is exactly what we have on the right side there. So our left side equals our right side. So we can say, therefore, the solution is 6, 10. Right? So that's just going through the elimination process again, but working with the idea if we have a fraction, we need to clear that fraction to work more easily with those equations and those systems. All right, but how do you know when to use each method? How do you know if we should use substitution or if we should use elimination? And the key there is kind of in the names of the methods. So with substitution, we want to make sure that there's a variable isolated, or that it's like really easy to isolate a variable based on the equations that have been given to us. Because once a variable is isolated, we can just substitute in what that variable is equal to into the other equation, and we're moving along with the substitution method. So we want to use substitution if a variable is already isolated or it's easy to do so. Okay, so if it's easy to get that variable isolated or it's already isolated for you, we're going to use substitution. For elimination, if the variables are lined up over each other, or again, it's easy to do so, then we want to use elimination. So in today's note, really what we're going to do is I'm going to go through a couple examples with you, and then I'm going to get you guys to go through a couple of examples. A couple of them I might just help you get started in case there's some parts that might be tripping you up, but it's going to be more I try, you try for the rest of the note today. All right, so let's take a look. Okay, so solve the following systems of equations. So if we look at this, no matter which one we're using, we always want to number our equations. So we have equation 1 and we have equation 2. Now remember what we just said. For substitution, we want there to be a variable already isolated or it's easy to isolate a variable in 1 or 2 steps. Okay. For elimination, we want all of the variables lined up over each other and the constants lined up over each other. Well, in this case, if we look, equation 1 already has a variable isolated, right? Y is already isolated. So that tells me we're going to use substitution. So we're going to sub. Okay. And I like to have different colors here, but in this case, since we already have y isolated in equation 1, we can say that we are going to sub equation 1 into equation 2, right? Because we can just take that, what y equals, and plop it in for the y in equation 2. So I'm going to rewrite my equation 2. And then instead of writing that y, I'm just going to write my brackets because I know that's what where I'm going to substitute in is equal to -3. So I'm going to take what was in my equation 1. I'm going to take what was in equation 1, right? That's what y is equal to, and I'm plugging it in here. So we're going to have a -3x plus 5 goes in here. And then we just use algebra to work towards solving this. So we'll have 5x, so we'll distribute that 4 in. So a -4 times a -3 is going to be a plus 12x. And then a -4 times positive 5 is a -20. 5x plus 12x is 17x. And then we'll move that 20 over by adding it. So we'll get a positive 17 as well. And then finally we'll divide both sides by 17. And we're going to get that x is equal to 1. Okay, so we have x is equal to 1. Now, kind of after we decide which one we're going to do and we actually start the method, the steps are the same after that. We've solved for x. I'm just going to draw my arrow so I can communicate where I'm going from here. Now I'm going to sub x equals 1 into, and in this case, because we've already isolated for y, I'm going to sub it into equation 1. So y equals -3, and then again, in place of an x, I'm going to substitute that 1 plus 5. Okay, -3 times 1 is a -3 plus 5, so y equals 2. Right, and after we've, of course, got what we think is the solution, we then need to check it in our other equation. So we just used equation 1, so now we need to check our solution in equation 2. So I'm going to do it my left side, right side check. So my left side is 5x minus 4y, and my right side is -3. So I'm going to substitute in for x a 1, and I'm going to substitute in a 2 for y. So we should get 5 minus 8, which is -3. So that's great. Our left side equals our right side. So we can say, therefore, the solution is 1, 2. Okay? So that substitution, we would have seen it a few days ago. You're going to have a chance to practice that again later in this note. Let's look at the next example, though. So our next example, we have 5x minus 2y equals 24. And you know what? Before we do that, I'm just going to draw a line to kind of separate. Oh, gosh. Draw a line to separate our work so that hopefully they're not running into each other too much. But before we choose a method, just like all the other ones, we want to number our equation. So let's call this 1, and we'll call this equation 2. Now, if we look at this, if we can easily isolate a variable, then we should use substitution. But when I look at this, if I tried to isolate for y, I'm going to end up having to do some division, which is going to leave me with some fractions in either equation 1 or equation 2. Equation 1 looks like I already have my x's, my y's, and my constants kind of in the right place. I just have to do a little bit of rearranging in equation 2. So for that reason, I'm going to say let's use elimination for this one. Okay, so for this one, we'll use elimination. So for to get started, we're just going to write everything over top the way it's supposed to be. So for equation 1, we already have our x's and our y's where they belong, but for equation 2, we're going to have to do some rearranging. So we'll leave the 4x on the left, we'll add our 3y to the left, and then we'll bring our 13 to the right by subtracting it. Now in this case, we haven't seen an example in our notes, you would have in your homework, but we're going to need to multiply in order to get the magnitude the same on either our x or our y. And since my y's are smaller, I'm going to go with my y's because it looks like, unfortunately, I'm going to have to multiply both equations. So I'm going to try to get my y's to have a coefficient of 6 in front of them. So for that to happen, I'm going to have to multiply my equation 1. To make sure we know this is equation 1. We're going to have to multiply my equation 1 by 3. And my equation 2, because I have a 3 on my y now, so I'm going to have to multiply that by 2 to get it to be a 6. So let's go ahead and do that. If I multiply 3 by everything on equation 1, I'm going to end up with this. That's my equation 1. And then for equation 2, I'm going to multiply everything by a 2. So I should end up with an 8x plus 6y. And then negative 13 times 2 is a negative 26. Okay, so now that we were able to get the number the same on our y's, we can eliminate those. We have a negative 6y and we have a positive 6y. So because they are opposite signs, we are going to add them together. So let's just make sure we make a note of that. We are going to do 1 plus 2. And we'll put a little plus sign next to our equations. So 15x plus 8x is 23x. My y's cancel away. And then 72 plus a negative 26 is 46. Okay, we'll divide both sides by 23. You can see hopefully now the process is starting to look the same at this point. And we'll get x is equal to 2. All right, and then from there we will, I'm going to kind of jump all over here, but we will substitute x equals 2 into the equation. We'll just kind of go this way. So we'll sub x equals 2 into, and then we just have to decide which equation we want to substitute it into. So equation 1 looks fine. It doesn't really matter. We'll sub into equation 1. They both look, in terms of difficulty, about the same. So let's say that our equation 1 is 5, and then instead of x, we're going to substitute in that 2 minus 2y equals 24, and we'll have 10 minus 2y equals 24. Then we'll bring the 10 over by subtracting it. So we'll have 24 minus 10 is 14. And we'll divide both sides by negative 2. So y will equal a negative 7. Okay, and then the last part is we need to make sure that that solution we think is true is also going to work in the other equation. So we just looked at it in equation 1. So now we are going to check in equation 2. So we'll set up our left side and our right side. Left side, right side. The left side of equation 2 is 13 plus 4x, and the right side is a negative 3y. So in place of our x, we're going to substitute that 2, and in place of our y, we're going to substitute a negative 7. So 4 times 2 is 8, plus 13 is 21, and a negative 3 times a negative 7 is also a positive 21. So we can say the left side equals the right side. So therefore, the solution is 2, negative 7, making sure that our x comes first and then our y. Okay, so what I would like you to do is I would like you to pause and try the next couple. See if you can determine which strategy you should use. I'm going to put the work up for the next example, and then I will come back to you guys so you can see the solution, and then I'll do the same for the fourth example. Okay, so try that third example. So there is your solution to your third example. Hopefully you could see that elimination was the method that should be used. If you subtracted your equations and then you worked through those same steps of determining what y is and then subbing in to determine what x is, and then of course checking your solution before writing your therefore statement. I'm going to pause the video again and give that next example a try. Okay, and there's the solution for that fourth one. So hopefully, again, you could realize that elimination was your best choice because you had the same magnitude already on your y variables. And so you could subtract those equations to figure out x, and then sub in to figure out y, and then check your solution before writing your therefore statement. So we'll take a look at a couple more examples, just a little bit different. Okay. So on this next example, again, I'm going to have you guys give it a try, recognizing that you are going to have to try to clear the fraction. But in this case, before I'm going to let you guys go ahead and do it, take a look at, we have equation 1 and we have equation 2. Remember, we want to use substitution if a variable has already been isolated. So we looked at this way back when we first started looking at substitution in linear systems, and they've already done the work for us. They have y isolated in equation 1 and y isolated in equation 2. So just based on that alone, we should be wanting to use substitution. Okay. What I'm going to say is give it a try. Substitute in one equation into the other. So let's just write here that we're going to sub 1 into 2. Okay, that's what we should be trying to do. We're going to substitute equation 1 into equation 2. Go ahead and substitute the equation in. Then once you've substituted in, work on clearing your fraction and working through the substitution method, and then check back to see what the solution is. So pause your video to do that, and then come back to see the solution. So there's the solution for that. Hopefully once you substituted 1 into 2, I'm just going to highlight that point. This is what it looks like when you substitute 1 into equation 2. Okay, from there we needed to identify our lowest common denominator, which would have been 12, and multiply everything through. And then the process was essentially the same. Okay, this next equation, again, you want to look at whether we should use substitution or elimination, and then you're going to want to work on clearing the fraction. So pause the video again and see if you can work through which method should I use, and then clearing the fraction to kind of move through that method. Okay, and there's your solution for the next one. Hopefully you can see, I'm just going to kind of highlight some points. The first thing I wanted to do was eliminate our fractions. So right off the bat, I multiplied equation 1 by its lowest common denominator, and I multiplied equation 2 by its lowest common denominator to get some equations with no fractions. Then from there, I assessed what I needed to multiply by in order to continue with my elimination method. Okay, this third one, I want to get us started together, and then I'm going to let you guys carry on with solving it. Okay, when we look at this first one, you could be thinking substitution, because maybe we could easily take equation 2, I'm just going to label these 1 and 2. Maybe we could easily take equation 2 and rearrange for y, but then we're still going to be plugging into all of these fractions, which are going to be difficult to deal with unless we clear them. So the first thing we're going to want to do is we're going to want to clear the fraction. So let's deal with clearing the fractions, and then we can kind of reassess if we should do elimination or substitution. So we only have fractions in our first equation here. Okay, so we have a denominator of 4 and we have a denominator of 3. So that means our lowest common denominator is going to be 12. So we have to multiply everything by 12. And so I'm just going to rewrite that because we won't have much room. I'm going to multiply 12 here. I'm going to multiply 12 here. And I'm going to multiply 12 by 1. Okay, so if we multiply that stuff through, hopefully we can see that the first fraction there, the 12 and the 4, that's going to reduce to a 3. So we're going to have 3 times x plus 3. Okay, and that second fraction where you have 12 times y minus 1 over 3, the 12 and the 3 are going to reduce down to 4. And we're still going to have that y minus 1. And then finally we have 12 times 1 is just 12. Okay, so from there, we need to distribute to simplify this equation. So we're going to distribute our 3 in the brackets, we're going to distribute our 4 in the brackets. So 3x plus 9 plus 4y minus 4 equals 12. And then we'll just work to combine some like terms. So we have 3x plus 4y, and we can combine that 9 and that negative 4, so it's a plus 5 equals 12. And then finally, I'm going to bring that 5 over to the other side just so it's with the other constant. So 3x plus 4y equals 12 minus 5 is 7. Okay, so this is really my new equation 1. Okay, we've gotten rid of the fraction. We've kind of simplified it as much as we can. So I'm just going to write this new equation 1. Trying to do this so that we can in an organized manner. So let's just let's do this. Let's do 3x plus 4y equals 7. That's going to be my equation 1. And I'm going to take equation 2, and I just want to write it right below it so that we can see them lined up with each other. And we have 2x minus y equals 1. Now, hopefully you can see those two equations together. We have our x's over our x's, our y's over our y's, and our constants over our constants. So that tells me, if that's the case, then we should be using elimination. So now that we've gotten it set up to that point where we have everything right stacked over each other, go ahead and work through the process of elimination in order to solve this equation, and then come back to check your solution. Okay, so there's a lot more arrows in this example than I would care for. But where we left off was we had these new equations, 3x plus 4y equals 7, and we had 2x minus y equals 1. Okay, so if we follow our arrows here to the right, it looks like we can multiply equation 2 by 4 in order to get the same magnitude on our y variables. So we did there. And then once we did that, we were able to add the equations together to eliminate our y, and we solved for x. So we found x was equal to 1. And then we substituted that x value into equation 2, and we found that y was equal to 1. And then from there, I'm just following my arrows, we went ahead and checked our solution in our other equation, so in equation 1. And I just want to point out which equation 1 we used, because obviously that first equation 1 with all the fractions would have been difficult. So this equation 1 over here, where we had cleared all the fractions, is the one we actually did the check in. Okay, so we had checked it in that equation 1, where the left side was 3x plus 4y, and the right side was 7. When we checked it, we found that the left side equaled the right side, so then we could write our solution was, in fact, 1, 1. Okay, so keep practicing your substitution and elimination. The more you do it, you'll find it's easier once you just get the process started. Once you decide and do that first couple steps, it's the same in terms of algebra, in terms of solving it for x, solving for y, and checking. Okay, that is it for today.